guys warm up. You may need your previous notes, the investigation that we did. One of these lines is the correct line. You are trying to figure out which one it is. Here are your clues. I am not a vertical line. My y-intercept is greater than -3. My slope is less than 1. I am perpendicular to another line on the graph. I am parallel to any line with a slope of 0. I'm going to give you a couple minutes to think about that. Look at these different lines. Which of these do all of these apply to?
E.
E. Why E?
Because the slope is the y-intercept is greater than -3.
Okay.
And the slope is less than 1.
Because that's 1/4.
And it's perpendicular to A.
I wouldn't say that's perpendicular. It does intersect, but not necessarily perpendicular. So, is it perpendicular to another one?
C.
Eventually that's going to cross somewhere, but I don't think that's perpendicular. So, it doesn't fit all of them. Do we have another one?
D.
D. Why D?
Because the slope is 0.
Okay, the slope is 0, which is less than 1.
And the y-intercept is greater than 3.
Because of that 2. Fit the others.
It's perpendicular to F.
Perpendicular to F, it makes that T.
And it's a parallel line with any slope of 0.
Correct, because it has the same slope. And what about this one?
It's not 0.
And it's not a vertical line. It is line D. Who else thought line D? Did we think of any other line? It's okay if you did. We can talk about it. Right. So E had some of those, but not all of those. I'm trying to think of another one that would have possibly worked. I think E was the only other one that was close. Maybe B and E might have been on the same page. All right. So previously, last week, we talked about parallel and perpendicular lines and how to figure out if they're parallel and perpendicular, looking at the slopes, things like that. Now we're going to actually define them and talk more about them. So I'm going to have you guys write down these definitions. Let's break down those. So, parallel lines are lines that never intersect, which we kind of talked about. I don't remember exactly what we said, but basically they go in the same direction, they don't cross, they never intersect. And then we also found out that they have the same slope. I'm going to add and different y-intercepts. So they have to have both things, the same slope and different y-intercepts. When you get to geometry, they're going to use parallel and perpendicular lines a lot. So these are the symbols for those. For parallel lines, it's just 2 lines. But vertical. For perpendicular lines, they are lines that intersect at a 90-degree angle. You'll learn more about that in geometry, but they make that T. And then they have negative, opposite, reciprocal slopes. So we kind of talked about that as they were flipped, they were reciprocals, and they had one positive, one negative. So that's called a negative reciprocal. The flipped version of a number where one is positive, one is negative. Or a fraction that is flipped and the signs are switched. And this is the symbol for perpendicular lines, your upside down T.
So if it's a positive, then does it have to be a negative, right?
The next one, or the other one, has to be a negative, yes. Yeah. Alright, so once we're finished writing the definitions, we are going to look at some negative reciprocals. Right, so if it asks about negative reciprocals, what would the negative reciprocal of 3/4 be?
2 negative 3.
For 3/4, it would be negative 4/3. You take it, you flip it. If it's positive, you make it negative. What about 2?
1 negative 2.
Negative 1/2, because all your whole numbers are over 1, so negative 1/2.
Wait, so shouldn't the 2 be negative 2?
Because the original one, so 1 can be positive, 1 can be negative. They both can't be the same.
Oh,
Negative 7/8, positive 8/7. What about 1?
negative 1.
Negative 1. And then this one is a little tricky because if 0 is over 1 and I flip it and make it negative, what would that be? No?
Undefined.
Undefined. So 0 and undefined are negative reciprocals even though they don't look like it. Those will be trick questions.
Wait,
to
what
keep
if they
in mind.
both are negative? You make the both of them positive?
Then they wouldn't be negative reciprocals.
Oh,
1 has to be a negative, except in 0 and undefined. That's the only example where it doesn't count. Alright, so one portion of parallel perpendicular lines is being able to determine are whatever you're given parallel, perpendicular, or neither. So we're going to do that by finding the slopes of these. So off to the side, I'm going to rewrite our slope formula. Our y2 minus y1 over x2 minus x1. And we're going to find the slope for both the line segment AB and the line segment CB given the points. So if it helps you label them, x1, y1, x2, y2, and use your formula. 6 minus 3 equals 2, over 2 minus a negative 2, or if you want to put 2 plus 2, that's also fine. What would the slope of AB be?
Three over 7. I mean 8.
It is 3 over 4.
4. But like, doesn't the change to plus sign?
Yes, it would be 2 plus 2.
It's like, oh, that's 2. I thought it was...
Okay, so let's do the same thing. Find the slope of CD. You have 3 minus 0 over 3 minus a negative 1. It would be 3, not over 0. Over 4. Okay, so we have 3/4 and 3/4. Are these parallel, perpendicular, or neither?
The parallel?
Parallel, because they have the same slopes. So you can either use the symbol or write out the word parallel. on that so far? Let's do another. For number 2, same thing. We have 4 minus 2 over 5 minus 0. What would your slope be? 2 over 5. And then if we do the same thing for CD, 3 minus 8 over 3 minus 1. Negative 5 over
7.
3 minus 1 is 2.
Oh, I thought that.
2/5 and negative 5/2 are perpendicular. So you can see the slopes have been flipped. One is negative, one is positive. They are negative reciprocals. They are perpendicular. Questions so far? Okay. Let's do 3 and then we'll move on to the next page. AB, we have 6 minus 8 over 2 minus a negative 1. On the bottom, it is 3, yes. Negative 2/3, and then if you find the slope of CD, we have 3 minus 2 over 3 minus a negative 1. One over 4. So these would be parallel, perpendicular, or neither. Neither, because they're not parallel, they're not perpendicular. You would just write out the word neither. Now, there are some other neither, neither cases. When the numbers don't look anything like each other, that's obviously a neither. But if they look similar but slightly different, so let's say I had negative 2/3 and positive 2/3. They're not parallel because one is positive, one is negative. They're not perpendicular either because one isn't flipped. That would be a neither, neither case. So be careful because those might trip you up. Go on to the next page.
Well, it can't be negative.
We're going to do one more of these and then jump on to something else. Number 5. Slope of AB. 7 minus a negative 2 over 0 minus 0. 9 over 0. It is that, but we're going to hold that thought. Right, and CD, negative 5 minus a negative 5 over 6 minus 3. Over 3. Right, just looking at these two, would we say these are parallel, perpendicular, or neither?
Neither.
And that would be an expected response. But you have to remember to simplify these all the way. So 9 over 0, we know is what? Undefined. And 0 over 3 is what?
0.
0. 0 and undefined are parallel, perpendicular, or neither?
Neither. Wait, why? Because they don't have the same number. They aren't flipped or something.
They're negative reciprocals, even though they don't look like it. Because this is going to be some x equals, and this will be some y equals, and x equals and y equals are always perpendicular. They always make 15. So those will be ones you have to remember. Right? Do we have any questions on how to find if they're parallel, perpendicular, or neither based on the slopes? Or finding the slopes? Then we have to do the same thing, but now it's in equation format. So for number 9, would these be parallel, perpendicular, or neither?
Parallel.
Parallel. How do we know that?
Because they have the same slope.
And
Different y-intercepts.
same slope and different y-intercept. Yes, these are parallel. What about number 10?
Perpendicular.
Perpendicular. How do we know that?
Because the slope is flipped and it has changed to a negative.
So both things. It's the reciprocal and one is positive, one is negative. They are negative reciprocals. Alright, what about 11?
Neither.
Why neither?
Because they aren't flipped and they don't have the same y-intercept. I mean the slope.
Same slope. Yeah, so they don't have the exact same slope and they're not flipped. So this is in neither case. Right? Then some of your equations won't be solved and you have to solve them, yes. Let me do this and then I'll make it pass. So for number 12, we would have to solve both of them. How would we get this equation back in slope-intercept form? Subtract x on both sides. So 6y equals negative x plus 30. Divide everything by 6. So y equals negative 1 6x plus 5. Some of your equations won't be in the same state when you go to solve them. How would we solve the other one?
Just divide by 3.
Divide everything by 3. So y equals 6x minus 2. Are these parallel, perpendicular, or neither?
Parallel. Perpendicular.
Because these are flipped, one is negative. They are negative reciprocals. We're going to do a couple more of these. Oh, did I not? Hold that up. Alright, number 15. Are those parallel, perpendicular, or neither?
It's perpendicular.
So I was hearing two different things. This one is similar to 11, but different at the same time. Because yes, these are negatives of each other, but if I do 1 over 1 and negative 1 over 1, these do simplify. These are negative reciprocals. These are perpendicular.
Oh, I thought you said 32.
What about 16? Those we have to know the slopes of these. So the slope of a y equals is what?
0.
And a slope of an x equals is
And 5.
undefined. So if we have a 0 and an undefined, those two are parallel, perpendicular, or neither. You could also graph these, like draw a rough sketch of them. I'll do that really quickly. You can do that if you so choose. So your x equals negative 1. That's not and this is a little crooked, but your y equals 6 will look something like this. So they would make that t, and you can see that. Now, if they were the same, like they were both y equals or both x equals, those would be parallel. Or if it was like any of these equations and one of these, those would be neither. Right? Are there any other questions on this page that we want to see you go over or have questions about? Right, so the next page we're going to start tomorrow. Wednesday, we're going to review / maybe after tomorrow we review.
See?
Thursday is your quiz. Friday we're going to go over the quiz. Monday is your test. Tuesday and Wednesday are your flex days. So you're only getting 1 day for your test and 2 days for your flex day.